Let's move forward. So here you can see that we will convert our images into a NumPy array, as you can see here, np.array image1. Similarly, we will use cv2, that is OpenCV, and a function called cvt color. What this will do is, this will convert my image into a grayscale image. So image1 is our source image. We are converting into a NumPy array, and then we are converting into a grayscale image. Similarly for the image2 also, we are converting into a NumPy array. Image2 our is a destination image, and then we are converting into a grayscale image. Here you can see that I have also created a mask which is similar to the source image, the image1, and it will contain all zeros. This image will be stored as a NumPy array and it will contain all zeros. Let's run this and create our mask and convert our images. So here it has created an empty mask and also converted our images into grayscale. Let's move forward. So next what we'll do is we'll load the face detector and face landmarks predictor using the dlib. So here you can see that we have loaded the detector using dlib.getFrontalFaceDetector. It is already defined in dlib, the getFrontalFaceDetector function. Similarly, we'll use the shape predictor, which will be loaded using the shapepredictor68 facelandmarks.dat file. After loading these detector and predictor, we will store the height, width and channels of the destination image using the image2.shape function. Other than that, we are also creating a new face, that is np.0, and pass the height, width and channel. Let's run this cell and create the empty image with zeros. So this cell has completed. So our empty image has been created, which will be used further for face swapping. Now this is the most important part. Here you can see that firstly we are working on the face 1, that is the source image. In this source image we are creating a function which will detect the landmarks using the predictor function and store them. So first we need to pass the image to detector, then that object will be used to extract the landmarks using that predictor. Then storing the extracted landmarks points x and y into the landmarks, as you can see here, x and y. And we are going to segment these into the triangles. So for that we are using this points equal to np.array and convex hull. Similarly, we'll pass this convex hull and the mask into convex poly and apply a bitwise operator on the face 1 image. After that, you can see here that we are doing the triangulation. So the triangulation, we are using the bounding rectangle and pass our convex hull as we have created above. Similarly, we'll also divide it into a 2D using the subdiv function. Next, this subdiv function will insert the landmarks point also, as we have found above. Similarly, triangles also using the getTrianglesList, and then all this is stored into a NumPy array. So here you can see that the triangle is stored into a NumPy array using the np.array. Next what we'll do is we'll find the indexes of the triangles. So for t in triangles, we'll store 3 points and we'll store the rectangle indexes into these points. Next you can see that we have created an index point 1 where we have used np.where and we are storing the points where points equal to point 1. and all axes. Similarly for point 2 and similarly for index point 3. In the end, what we are doing is we are finding out that if index point 1 is not none and index point 2 is not none, and similarly for index point 3, then the triangle will be index point 1, point 2 and point 3, and we'll append the triangle into indexes or triangle. So this is the most important step to find out the triangulation of the images. We are working on the source image. So let's run this cell and complete this step. So as you can see, it's completed. Now we'll perform the same operation for the destination image, the phase 2. We are also extracting the landmarks for the image 2. So let's run this cell and perform the same operations for image 2 also, that is the destination image. The next step will be creating an empty image with zeros. Why this is important? Because it will be used for further processing for face swapping. Let's run this and convert new faces and new mask.